All right, so here we go. We're going to do projectile motion in 2 dimensions. So that means that not only is it moving vertically, but at the same time it's moving horizontally. And the key to doing all these problems is an amazingly cool fact, and that's that horizontally, when you have an object moving, it's going to have constant velocity. And so we have our constant velocity equations, which I'm going to keep in blue here. They're very simple to use, and that's for horizontal movement. Instead, in the vertical plane, we're going to have constant acceleration. We'll use negative 9.8 or sometimes negative 10. And that means that vertically it's going to be accelerating. You can see how these red dots show increased spacing as they're falling because it's speeding up due to the acceleration due to gravity as it falls. So in the vertical plane we've got acceleration, but horizontally we've got constant velocity. And both of those things can be solved independent of each other, which is very cool, and that enables us to solve these problems. When we're done, we'll be able to bring them back together. So we'll have this horizontal velocity that stays the same the whole time. We'll have our vertical velocity, and this would be at any moment in time, but generally we wait and talk about it at the end, so right before it hits the ground. We'll have our final vertical velocity here in red, and then we can combine those two to come up with our overall velocity at a given angle right before it hits the ground. And so we got a little Pythagorean theorem, a little arctangent to find that angle and that hypotenuse. So that's the idea. I like this image to sort of just make it brutally clear. So we have horizontally, notice the spacing is nice and even, and the ball moves at a constant velocity. So if there was no gravity, this is what the ball would do. It would just move along at a nice constant speed horizontally. On the other hand, if we didn't have horizontal motion, we had gravity but only vertical, then the ball would just fall like this. Okay, so it'd be speeding up as it falls. And these are just like the problems that we've already learned how to solve. Okay, but when we combine the two, we get this 2-dimensional projectile motion, and you'll notice that it does both at the same time. It's moving horizontally in a regular pattern, and it's accelerating downward at the same time. Okay, and that's an important note. When we go to solve these problems, the time in the horizontal and the time in the vertical, we got to use the same time. And that's going to be very powerful for us to solve the problems. So let's take a look at a little problem here. So we have a cat that's going to be thrown horizontally off of a little 2-meter high truck off the back of the truck. It's 2 meters high and it gets thrown sideways. So this is very similar to this. We have an initial horizontal only velocity of 5 meters per second moving to the right. And then the cat's going to accelerate downwards and obviously land safely on the ground as cats do. If I tried to solve the horizontal part, I'd notice that all I know is the 5 meters per second horizontally. I don't know how far horizontally it's going to go, and I don't know the time that it's going to be in the air, so I'm stuck and I can't solve the horizontal. When we look at the vertical plane, however, we have enough information because vertically the initial velocity is 0. And please realize that even though the cat has 5 meters per second velocity at the beginning, that's all horizontal. And vertically, we have 0 initial velocity. So we're going to solve the vertical part here with 0 initial velocity, a final vertical velocity that we don't know. The acceleration vertically, we do know. It's negative 10, or I'm going to use negative 9.8 this time. The time that it takes to fall, we don't know, but we do know the displacement is negative 2 meters. And the negative, obviously, because it's going downwards. And I should say that if you're not good at solving these types of problems, that's going to hurt you a little bit here. And you might want to go back and review the last unit and make sure you're able to solve 1-dimensional motion with acceleration before we go and do all these. Because then this should be fairly straightforward. We know 1, 2, 3 things, and whenever we know 3 things we can solve, we grab this equation. I can get the final velocity. I know to make it negative because it's going downwards. I get a negative velocity of 6.26. I think you get around negative 6.3 something if you use 10 instead of 9.8. In any case, then we have the final velocity, so I can go ahead and work backwards here to get the time. Solve for t here. And I get a time that's 0.639 seconds while it's falling. So that time while it's falling, 2 things are happening. It's falling vertically. That's how we calculated the time. But during that same amount of time, it's moving horizontally. So now that we know the time that it takes for this actual path, because this is the actual path that it takes, now that we know the time, we can go back and revisit the horizontal. So let's see what happens. So horizontally, now that we know the total time, I can now get the horizontal distance. So this is the distance horizontally that it moves while it was falling those 2 meters. And so now I know the horizontal plane. And notice I don't have an initial or a final velocity when I'm talking about horizontal. I just have one velocity, and that's because I have constant velocity. Instead, in the vertical, I got to be careful. I have initial velocities, and I also have final velocities. Okay, so here's what we ended up having. We had the cat moving at 5 meters per second at the start, only horizontally, and notice there's no vertical part to it. Now, as the cat's falling, it's moving sideways, and the vertical component here, here, here keeps getting bigger and bigger, and then right before it hits the ground, it's going negative 6.3 vertically downward. It's got 5 horizontal. And now we need to know, well, what's its overall velocity? So I'm going to take the horizontal velocity, the overall vertical velocity. I can do a little Pythagorean theorem. That's easy. And using the Pythagorean theorem, I can solve and see that I get around 8 meters per second is the actual total velocity, because it's a combination of both the horizontal and the vertical as it's about to hit the ground. I need to know this angle because this is a vector, and to communicate a vector, I need to know the angle as well as the magnitude. So the magnitude is 8 meters per second. I do a quick little arc tangent as we learned how to do in the first unit, and I can get that I've got 38.6 degrees, right, down from the vertical. If you drew the triangle the other way, you could also get this angle from horizontal. Depending on which way you drew it, looks like I drew it with the horizontal. So this is going to be 51.4 degrees. We'd call that down from horizontal as our solution there. And that's how we do these problems. I'll do another one in a second.